Here is an algebra machine. The algebra column shows us what happens to the unknown. Solve the equation, show and explain all your steps. Okay, so when we see an equation like this, we sort of want to think about PEMDAS, order of operations, first, so that we can undo them backward. The y plus 1 is together above this line, so it's almost as if it was in parentheses. And if you think about it, it also could have been written this way, right? So it's as though y plus 1 is in parentheses. Then we divide it by 3 in order to get 2. So if you wanted to reverse this, you would have to do the multiplication division part first, and then the parentheses. Okay, now let's look at the chain over here and see that that's true. We started with a number y. The first thing we did was added 1, and then we divided by 3 to get a result of 2. So if we want to work this backward, our first step should be the opposite of dividing by 3. We take our number 2, the opposite of divide would be multiply, and 2 times 3 is 6. Okay, continuing up, the opposite of adding 1 would be to subtract 1. So we're going to take the 6 minus 1 and get 5 as our input number. Okay, let's do the same thing over here a little more formally. So if we're doing multiplication division first, the opposite of divided by 3 would be times 3. It would cancel on this side, and on the right side, 2 times 3 is 6. Now, because parentheses is the only thing left, I don't need it anymore. Okay? But I am ready to get x alone from the expression in parentheses. I see plus 1. My inverse operation would be minus 1. And sure enough, we see that y is 5. Okay, let's do this again. Here's another algebra machine. Compare the algebra column, solve your equation, and then show and explain your steps. So we had a number. It doesn't even give us the equation this time. We need to put it together. We had a number x and we added 7. Then we multiplied by 3. So I need this binomial to be multiplied by 3. I need to put it in parentheses. From this expression, I'm going to subtract 2. And then finally, when I have this entire thing all put together, I'm going to divide everything by 5. My output will be 11, which means my equation is 3 times x plus 7 minus 2 over 5 equals 11. Okay, so there are different ways to solve it, but just for our purposes now, because we want to undo each of these steps, we're going to be very specific about solving it that way. If we started with 11, and our first step was to do the opposite of divide by 5, we're doing 11 times 5, which is 55. Okay, from 55, we're going to do the opposite of subtract 2, which is add 2 and get 57. Okay, from there, we're going to do the opposite of multiply by 3 and divided by 3. 57 divided by 3 is 19. Okay, from 19. Opposite of add 7 is subtract 7, and we get 12. Our input number, our x, must have been 12. Okay, to do this more formally, we said that when we see a big division line, it's essentially parentheses. So that has to happen last. If we're thinking of PEMDAS backward, any addition, subtraction would happen first, multiplication, division, then the parentheses that we're talking about. So in this case, the first thing to happen as we come backward is division by 5. The opposite of dividing by 5 is multiplying by 5. We do it on one side, do it on the other side, and we get 55. Okay. Now that the only thing left is this big parentheses, we don't need the parentheses anymore, and we have just the expression from the top. Okay. Working PEMDAS backward, the first thing we see is subtraction. The inverse of minus 2 is plus 2. And the 2's cancel. And this is how we get this number, 57. Okay, still considering PEMDAS backward, we come to the next term, multiplication division. A number in front of a parentheses is multiplication. Our inverse will be division, and that's how we get this number, 19. Okay, again, we've reached the parentheses, so we're up to that next. But once it's the only thing left on that side, we don't need it anymore. So we see plus 7. Our inverse operation would be to subtract 7. And sure enough, we get that our original value, our x, is 12.